What is React Spring, and how can it make our lives better as developers? My name's Alec Larson, and I'm co-author of React Spring, along with Paul Henschel, who wrote the first eight major versions of React Spring. I joined the React Spring organization at the beginning of April. Shortly after, I began rewriting the animation controller for version 9, which is currently in beta. Apart from my work in open source, I'm working on a few secret projects with my design-minded co-founder, Alec Larson, who's also my brother. Our latest project is Light Timer, the best timer app that lives in your menu bar. In addition to basic timers, it comes with a stand and sit timer, a focus and break timer, and it's made with React. It's animated with React Spring, and it's driven by React Native Mac OS, which is a community fork of React Native that I help maintain. Sign up for the beta at lighttimer.com. So animations are more important to UX than you might think. Sure, you could write an app without any animation, and maybe even some people would use it. And sure, no animation is better than having poor animations that turn people off. But taking the time to perfect your animations can have a compounding effect on your business down the road. Animation isn't something you churn out. For it to make a difference in your project, you need to harness your inner Picasso. If you can't be passionate about the animations in your app, why do you expect anyone else to care? When you truly care about providing the best experience, your animations become works of art. Animation builds trust, especially when it's thoughtful enough to make an impression. It shows that you care enough to put in the extra effort. But remember, there's also a fine line between inspiring and distracting your users with your animations. Good animation adds flair to the everyday actions your users take. But great animation guides the attention of your users to help them get things done faster. Figure out where you want your users' focus and design your animations around that. For example, that's what I did with Light Timer's website. When I first implemented the entrance animation, I had the logo fading in last. The trick is to fade in the logo earlier, so it's not stealing attention from the bottom half of the page. Notice how your eyes are attracted to the last moving component. Animation gives your web app a native feel, because native apps are always animated, and web apps are not typically animated. Easing functions are another way to improve your web app. Also known as linear easing, I think we all agree that it leaves a lot to be desired. Bezier easing, like ease out quad, can help, but we can do better. And that brings us to spring easing, the best choice for animations in React today. By default, with React Spring, your animations don't have explicit durations or easing functions. Instead, your animations are driven by Spring physics, and it's worth taking the time to understand why this is. Springs are physical. They have mass, tension, velocity, and friction. When a spring has zero friction, it never slows down. Its velocity remains constant as it would in the vacuum of space. And because of this, the circle always bounces back to where it started from. Friction decreases velocity over time. In the real world, nothing ever slows down, according to some predefined easing function. And your animations shouldn't either. Spring physics make your animations feel natural. Springs are responsive. They can follow each other around, constantly adjusting their velocity without sudden and unnatural changes in motion. And because of this, springs are the only reliable way to gracefully transition from a swipe gesture to an animation. Springs are intuitive. once you have a firm grasp on how the physical properties of a spring affect its movement, achieving the desired motion is easier than you might think. Tweak the friction here, a little less tension there, and you've got the perfect animation. Springs are the future. Look, it's 2019. If you're not using springs and only springs by 2020, you probably won't survive the coming robot apocalypse. And you can't say I didn't warn you either. So springs are clearly a great choice for animation, but springs aren't the only thing we want in an animation library. We also want a clean API for managing our animations, and now that we have React hooks, that goal can finally be achieved with React Spring. So let's take a look at useSpring, which controls the animation of one or more values. The useSpring function takes a set of props and returns a plain object with animated values inside. Your animated values can be named anything if you put them in the toProp. But you can also skip the toProp and pass your two values in directly. For your components to be animated, they must be wrapped with the animated function, exported by React Spring. This lets your component update itself transparently, which is much more performant than re-rendering on every animation frame. The animated function is also exported as the A function. This is convenient when animating built-in components. For example, the div component is wrapped for you automatically and exposed on the animated function. There's a small caveat with the animated function. You should avoid wrapping composite components with it unless you're okay with re-rendering that component on every animation frame. Not every value can be animated, but React Spring won't complain about it. Instead, React Spring falls back to basic assignment. So what can be animated? Numbers can be animated. Strings can be animated, like this CSS transform value, or this string that contains two numbers, or this hexadecimal color string, and even named colors can be animated. And last but not least, arrays can be animated as long as they contain animatable values. I want to make it clear that any prop can be animated with React Spring, not just style props. For example, even SVG props can be animated. In most animation libraries, you would need an explicit from value for this animation to work. In React Spring, the toProp is used as the from value, and no animation begins on the first render. So as you can see here, when we update the toProp, or the width in this useSpring call, it animates, but it didn't animate on the first render. To start your animations on the first render, you must include the relevant animated value in the from prop. As I click these buttons, notice how the animation is slower than in the previous example. This behavior is customized with the config prop. The config prop has default values for each of its properties, so you're not required to define all of them. The first of those properties is mass. The default value for mass is 1. The more mass you give to something, the more velocity it needs to speed up, and the more time it needs to slow down. The next property is tension, also known as stiffness. Higher tension makes friction less effective. Notice how the last spring has a slight bounce to it. Next is friction, also known as the damping ratio. Higher friction means greater deceleration and less bouncing. Velocity is the initial speed and direction. This property comes in handy for gesture-based animations. Notice how the animations all finish at the same time, even though their initial velocities are different. Let's see that again. Clamp prevents your animation from overshooting its final value. The most common use case for clamping is when you're animating opacity. This is without clamp. So because you're using a spring animation, there's that overshooting, and it looks really bad. But with clamp, fades in, and it's done. And finally, precision is used to determine when a spring has finished animating. Most of the time, you won't need this. For your convenience, React Spring provides some presets on the config export. In this demo, you can see each of the presets and how long it takes for their animations to finish. The gentle preset has the lowest tension of the presets. The wobbly preset has the lowest friction. The stiff preset has slightly higher tension than the default preset and also slightly lower friction. The result is a faster spring that bounces a little bit. And the slow preset has more than twice as much tension as the gentle preset and 4 times as much friction. And finally, the molasses preset has the same tension as the slow preset, but twice as much friction. So these can help you learn how the different properties affect the movement. By passing a config function, you can have different spring behavior for each of your animated values. If you ever need them, here are the config props supported by React Spring that are not related to spring physics. If you know what duration and easing are for, then you know that a kitten dies every time they're used. The decay prop is for animations that resemble curling, like scroll animations. The delay prop controls the number of milliseconds before the props are processed by the animation controller. As your component is re-rendered, new delays are kicked off. You can pass a function here too if you need to customize the delay of each animated value separately. The immediate prop makes your animations instant. Like the delay prop, you can pass a function. The cancel prop stops your animations instantly. Unlike the immediate prop, your animated values will not jump to the end value. The cancel prop can be a string if you want to stop a single animated value, or it can be an array of strings. The reset prop restarts your animations from their initial values, as if it was the first render again. Finally, the reverse prop treats the to prop like the from prop, and vice versa. So these two examples are equivalent. Unfortunately, they're cut off. The remaining props of use Spring are event listeners. The onStart prop is called whenever one of your animated values is about to start animating. It's passed an animation object, which can help when debugging. The onFrame prop is called on every animation frame with the latest values. And finally, the onRest prop is called whenever the last animations have stopped or been finished. The animated nodes returned by useSpring have 2 methods. The first method is getValue, which returns the latest value. And then there's the interpolate method, which effectively transforms the animated value on every animation frame. The return value is a new animated node that can be passed to an animated component. Also, if you ever need to combine multiple animated nodes, you can use the interpolate function exported by React Spring. By default, useSpring is in declarative mode. It updates its animations on every render. Declarative mode should work perfectly in most cases. But if you want to avoid re-rendering for some reason, imperative mode lets you do just that. Pass a props factory instead of your typical props object. The props factory is only called on the first render. To update your animations, you can call the update function with any props that you would normally pass to use Spring. With the stop function, you can stop some animations by passing specific keys, or you can stop all animations by passing nothing. There's also an imperative ref mode, where you pass a React ref into use Spring. In this mode, your animations must be started manually. Here's the interface of the use Spring ref. The controllers array is interesting. Controllers are the objects that manage your animations. Keep in mind, there isn't much documentation on controllers yet, because the hooks API usually gets the job done. One of my favorite features in React Spring is the ability to create scripted animations using an async function as the to-prop. The update function takes the same props that use Spring does, and it always returns a promise, which resolves once all the animations have finished. This lets you describe complex animation logic using async await syntax. There are 3 ways to chain animations together in React Spring. The first way is by an async function as the to-prop, but that can be overkill if you don't need arbitrary logic between updates. The second way is by passing an array of updates as the to-prop. So that would animate X to 100 first, and then when that's done, animate Y to 100. The objects in this array can have any use Spring compatible prop, like delay. The from prop must be defined whenever the to prop is an array or function. Otherwise, the animated nodes won't be created on the first render, and thus your animated components won't be connected to your animations. React Spring ensures that only one async to function is running at any given time. When a new to function is passed to use Spring during a re-render, the previous to function is interrupted. To avoid this, be sure to wrap your async function with the use callback hook. The third way to chain your animations is with use chain. When the use chain hook is passed just one array, it starts the animations of the first ref, and then when the first ref is done animating, the second ref has its animations started. You can pass an array of time steps if you want explicit delays. Notice how the delays are in seconds instead of milliseconds? This makes use chain feel like a higher level of abstraction, at least a little bit. If any ref has an undefined delay, it inherits its delay from the ref before it. When you're trying to chain animations across many different components, use chain isn't ideal. On Lighttimer's website, I have a chain of animations, but it's not implemented with use chain, because that would require passing refs up the component tree to the nearest common ancestor, and that gets messy pretty quick. Instead, I group the delays into an object. This way, you can easily get an overview of which animations start when, and tweaking the delays is super easy. In the future, React Spring could make this even better by providing a context-based API for animation timelines. What's more infuriating than waiting for a transition to finish just so you can interact with something on the page? Almost nothing, right? And when a transition's interrupted, there better not be any visual jumps. The use transition hook solves the problem of declarative interruptible transitions. It takes 3 arguments and returns an array. It returns an array of transition objects. The items argument can be anything. an array of values, or just one value. Note that this API could be changed in version 9, so your feedback on use transition would be priceless. The transitions array should be mapped into an array of JSX elements. And these elements will be animated as their associated items are added or removed. Each transition represents a value from the item's argument. The key and props of each transition object must be given to each JSX element for everything to work as intended. To determine the key property of each item, the key of argument is called. When the key of argument is null, the items are treated like keys. First, let's create a transition for a single component. I'm using an array to tell use transition when the component should be mounted or unmounted. We can skip the key of argument since the value 1 can be used as a key. And finally, we pass some props that describe the transition. The from prop must be defined with the initial values. The enter prop is applied to any items that were just added this render. Likewise, the leave prop is applied to any items that were just removed. So this is a demo of the code from the previous slide. The box is faded in when mounted and faded out when unmounted. Its background color only changes on the first render, so it's easy to notice when the component has been recreated. Notice how if I click fast enough, there ends up being 2 boxes mounted at once. To fix this, set the unique prop to true. This allows for components in the middle of their leave animation to be reused. And here's a demo with multiple values in the items array. I didn't get around to finishing this, so the boxes kind of jump when a box is added or removed. But this demonstrates how use transition can easily manage animations for multiple items at once. If you want to chain multiple animations for the enter or leave transition, you can pass an array of updates. The transitions of each item can be individually customized. For example, try passing a function as the enter prop, and it will be called whenever an item is added. You can even return an async function or an array of updates. The ref prop triggers imperative ref mode, which is identical to how useSpring works. The trail prop adds a stagger effect. When multiple items are added at once, their transitions won't happen at the same time. The config prop lets you set the default spring behavior of each transition. To customize the spring behavior of each item, try passing a function. The useTrail hook lets you control multiple springs with a single set of props. Every spring follows the first spring, but with a short delay to create a stagger effect. The main difference from useSpring is that you need to pass a number as the first argument, but the second argument of useTrail is identical to the first argument of useSpring. useTrail also returns an array of objects instead of a single object like useSpring. All right, so here's an example of useTrail in action. The first face follows the mouse, and the other faces follow the face in front of them. And here is a more advanced example of useTrail. I think this is pretty cool because it shows how the leader of a used trail animation can trail another animation, when I click, the trail goes the other way. Next is the use springs hook, which lets you control an array of springs. This is actually what powers the use spring hook under the hood. It takes the number of springs you want, as well as an array or function. It returns an array of objects that contain animated nodes. If you pass a function, it's called once per spring with a springs index. This also activates imperative mode, which means you need to start the animations manually. By calling the update function with a function argument, you can decide which updates are necessary on a per spring basis. And those are the 5 hooks exported by React Spring. If you have any ideas for hooks that would make React Spring even easier to use, open an issue so we can discuss it. The more ideas, the better. React Use Gesture is a package that provides declarative gesture handling, and it works perfectly with React Spring because it's made by the same guy that wrote React Spring. When I throw one of these tarot cards, React Spring uses the gesture's final velocity to determine the rotation as it flies off screen. By using dependency injection, React Spring can support multiple platforms. These are the entry points for each currently supported platform: DOM, React Native, Canvas, and WebGL. React 3 Fiber is a package that React Spring uses to support WebGL. It combines the React reconciler with 3JS for declarative 3D environments. Let's see how easy this effect is with React Spring. Just kidding, I forgot that slide. Okay. Currently, animations in React Native are driven by JavaScript. This often leads to janky animations because JavaScript can't send messages over the native bridge fast enough. I'll be working on a native frame loop when I get home, though, so that's pretty cool. And React Native will soon have the JSI, which allows for custom native objects to be exposed to JavaScript. Hopefully, this will make JavaScript to native messaging fast enough for 60 frames per second. When I found React Spring almost 2 months ago, I was like, this API is beautiful. How does it work? As I tried to understand the source code, I was like, this is pretty nice, but this variable name is confusing, and why is this like this? And so little by little, I tweaked and reorganized the controller class that manages animations for the Hook API, fixing bugs and adding small features here and there. Apart from understanding the internals better so I can fix my own issues, I also wanted to help lay a better foundation for future improvements because by this point, it was obvious to me how valuable React Spring is. And then, over 140 commits and 8 beta versions later, I'm the new co-author of React Spring, and even better, version 9 is around the corner with all kinds of goodies, including reworked TypeScript definitions. So try version 9 today by installing the next version from NPM. And whether it's positive or negative, your feedback is always appreciated. There are more examples on React Spring IO, the official documentation site, like a gooblob and a list you can reorder by dragging. People like those, I think. And there's more. The React Spring Examples repository is a great place to experiment. Setting up a local playground is as easy as running git clone and then yarn. And I have some cool stickers to hand out thanks to Mihai Cernuska. So come find me later for those. And follow me on GitHub at Alec Larson. Follow me on Twitter at alec.biz, where I'll be announcing a secret project later this year. Click the link in my pinned tweet if you need some chill house music to listen to while programming. That mix in that tweet is from my YouTube channel, New Loops. We already have 10 mixes ready for you, so smash that subscribe button if you like what you hear. And don't forget to sign up for Light Timer Beta at lighttimer.com. Thanks.